Welcome to Web Handling. My name is Dave Roisum. In this third clip in a series, we discuss how web thickness affects certain concerns in web handling and converting. We begin by somewhat arbitrarily defining different levels of thickness, even though the range is obviously a continuum. Most webs are thin, say 0.5 to 5 mils thick. Recall that a mil is 1/1000th of an inch thick. The upper end of this range is 5 mils and is about the thickness of a human hair. In metric units, this range would be 12 to 120 microns. Of course, there are thinner and thicker webs, but they are a little less common in terms of commercial production. While commercially produced webs do not get much thinner than the ranges shown here, they could get much thicker. However, we then enter a new set of behaviors that is not considered by web handling. That is, the whole new range of out-of-plane bending stresses that can no longer be ignored. We are no longer in the comfortable confines defined by web handlers decades ago, where the web is long, thin, and flexible. These would be the concerns of sheets, not webs. By far, the biggest area of concern with regard to thickness is its effect on various flatness concerns. Baggy webs can be challenging at any thickness, but perhaps a bit more as the thickness increases. The bigger effect is seen with curl, that is nearly non-existent on thin webs, but could be quite challenging with thick webs. Another area of big difference is the entire world of wrinkling and wrinkling treatment by spreading. While wrinkling is the #1 cause of waste and delay with thin webs, it is, for all practical purposes, non-existent with thick webs. Thus, it is good that we have so many spreading treatment options for thin webs. We need it. It is also fine for us that while we can't spread very thick webs, it is neither helpful nor needed anyway. Thickness has a very large effect on a couple of other web handling and a couple of other web converting issues. Air entrainment can be very challenging when webs are simultaneously thin, not narrow, smooth, and run at high speeds. We discovered that topic in the first clip in this series. On the other hand, bend radius can be a concern with very thick webs. This might require larger cores for winding and larger rollers for web handling. Finally, several converting challenges can get much worse with very thick webs, including cutting, guiding, and splicing. Thank you so very much for watching this module and my plant practical video clips. Stay tuned for more extremes of web handling.